Good. So today's lecture is about asynchronous JavaScript and what involves everything to understand about the JavaScript event loop. Let's explain what does asynchronous really mean. An asynchronous operation is an operation that doesn't happen now. It's an operation that is executed later. So every time you hear the term asynchronous, just understand that later I'm going to perform this, take care of the operation. So if we have a software that has, let's say, 4 lines of code, if this program was synchronous, that means it's going to execute in this order. First thing is line number 1. When line number 1 completely ends, now I'm going to start processing line number 2. When line number 2 completely ends, now I'm going to start processing line number 3, and so on. Line number 4 is the end of the current script. Now, this is if it was synchronous. What happened now when I process the same code, 1, 2, 3, 4, assuming line number 2 is asynchronous? If I'm going to run now this script, knowing that line number 2 is asynchronous, we start with line number 1, which is synchronous. So I process line number 1 completely. When it ends, I skip line number 2. I delegate number 2 to some other asynchronous environment to execute something there, and immediately jump to line number 3. Now let's say the line at number 2 is due to process now. I cannot do that until the end of my script ends. So an asynchronous action always requires a callback function or a value or data that's need to arrive in the future or later. You cannot read this value as your code is still processing. I can only read this value after line number 4 has ended. So let's say line number 2 was to read value from a database, read from DB. First of all, you don't need to wait for the results before you process line number 3 and 4. Okay? If you want to read something from the DB, you delegate this operation to some sort of threads that are going to inquire the data from the database and bring you back your value. Now, let's say the value from the database arrived. You cannot process it because once you delegated line number 2 to the async process, your scripts will going to continue to line number 3. You're going to finish number 3 completely. Let's say the value arrived. Cannot read it. You finish line number 3, you jump line number 4. You finish line number 4 completely. Now you can process any asynchronous value that arrived from the database. So we always process any asynchronous work, the values that we read, timers, promises, anything asynchronous, we process them later after the synchronous script has ended. Now, who's processing all of this code? In JavaScript, we have something called JavaScript engine. The JavaScript engine is the environment where you feed it JavaScript and it literally executes the code. So it gives you out some machine code as a result. And inside the JavaScript engine, we see single thread, one thread stack that is executing all your synchronous code. So I have a script of 4 codes, 1, 2, 3, 4. I'm gonna build an execution context, push them to the stack, and they will execute line by line. I cannot process anything until I finish line number 4. Okay? Let's say in line number 1 or 2, you need some variables, objects, memory. This memory, we call it heap. So a heap space inside the JavaScript engine is where all your memory space for your functions, objects, and variables. And the stack is basically a single thread where all your code executes. Every single time you call a function, another function is pushed with a new scope to the stack. This function calls another function, and it's a stack. So it's work as first in, last out. So after this is gone, we jump back to the previous context. When it's done, we jump back to the previous context. When the last one is finished, now this JavaScript engine is ready to process something else. So a JavaScript engine is just an environment where we execute JavaScript. And you will see once we talk about front end in the third week, you will see that the JavaScript engine is both compiler and interpreter. Both together. Its job simply to translate JavaScript to machine code. And within the JavaScript engine, we see two entities, stack and heap. Stack is where all your code executes. It's single thread, line by line. The work inside the JavaScript engine is always synchronous. So it's never asynchronous inside the JavaScript engine. And we have a space of memory we call heap where your variables live. Now, Google has implementation of this JavaScript engine. They call it V8. Mozilla, they have a version of the JavaScript engine. They call it SpiderMonkey. Microsoft, they have a version called Chakra. Apple, they have JavaScript Core engine. So these companies, they read the JavaScript specification and they implement their own JavaScript engine to live inside their products. So they can build a browser, for example, Chrome, that can run JavaScript. The browser that is called Firefox uses SpiderMonkey as JavaScript engine. Inside Safari browser in Mac and iOS operating systems, we have a JavaScript engine called JavaScript Core. And the way this JavaScript engine compile and interpret the code based on some algorithms is what determines which one is faster. And so far, Google is the winner in this game. They built really the fastest JavaScript engine on Earth. And you will see this V8 JavaScript engine in multiple products now, not only inside Chrome. So Chrome does have V8 inside to run JavaScript. You will see that Node project also depends on V8. You will see that MongoDB also depends on V8. They all take this V8, this JavaScript engine, and include that as part of their project that runs JavaScript. Why they choose V8? Because it is the fastest. At any time, any other company, they really compete and produce a more performant JavaScript engine, you will see some shift in technologies to use the different one. Any questions so far?
Not yet, Professor.
Good. So how does this asynchronous work happens. I'm gonna show you now something called event loop. So we know that we have some sort of JavaScript engine that runs all the synchronous code. So what happened if line number 2 was asynchronous? So line number 1 is synchronous. We finish it and then we start number 2. Line number 2 was asynchronous. We cannot process anything asynchronous inside the JavaScript engine. So we delegate the asynchronous work to supporting environment, to someone that can deal with this asynchronous action. Let's say it's a fetch request or database request or a timer. We delegate that to an asynchronous operation. In the browser, the supporting asynchronous environment, it's called Web API. So if your line number 2 was set timeout for a function, whatever the time is, this function is delegated to execute, preferably after 0 milliseconds. So what happened in the Web API is that the Web API tried to fulfill your requirements immediately, while after finishing line number 1, now you can immediately jump to line number 3. You kinda skipped line number 2. So let's talk now what happens to line number 2, which is an asynchronous operation. So let's say the operation was set timeout, which always comes that I need to run this code, preferably after this time. If this time was 0, the function is immediately pushed to a queue. We call it macro task queue. So this function is always pushed when the time is due. If it was 1 second, after 1 second, it will be pushed here. If it was 0, immediately it's pushed here. So when we set a time for set timeout, the function never execute right away. This time means push these functions to the macro task queue after this time. It does not mean execute this function at this time. So regardless of the time, let's say it's 0, the function is pushed immediately to the queue. Now my script is still processing. Line number 3, finish. Line number 4, finish. Now as we finished all the synchronous code, and now my stack is completely empty, this is only the time where there is something called event loop triggers. To take this function and push it into the stack inside the JavaScript engine to run also synchronously, line by line. If one of the lines require anything asynchronous, it's delegated to the asynchronous API. The asynchronous API may be fetch, maybe database, maybe whatever. Always the result of the asynchronous action is to push functions in a queue. Never execute the functions. And only when the stack is completely empty, the event loop triggers to take one function from the macro task queue and push it into the stack. That's basically how JavaScript synchronous and asynchronous runs. The main concepts here are the JavaScript engine is always synchronous. Execute scripts line by line. An asynchronous operation is delegated to an asynchronous environment. In the browser, it's Web API. The results of the asynchronous operation is always callback function, value. This result is always pushed in form of functions inside queue. The last and most important concept that we learn is the event loop. Why? If the JavaScript engine stack is busy, the event loop is paused, cannot do anything, even if the queue has 1 gazillion functions. Only when the stack JavaScript engine is empty, finish the synchronous code. Now an asynchronous function is going to be pushed into the stack to run synchronously again, line by line. So once the JavaScript engine is working, the event loop is paused. The moment the JavaScript engine finishes, the event loop works and push something more. So what we really want to accomplish here is to build applications that spend minimum time inside the JavaScript engine and never spend too much time here. Why? Because if I build a script with for line number 3 and 4 and 5, and each line takes a lot of time to process, not only I'm delaying execution here, but I'm not able to pick anything up from any functions that are queued in the macro task queue. So that problem, we call it blocking problem. We will take a look at this problem a lot in more details tomorrow. So the third concept that we really want to understand is we want to spend minimum time inside the JavaScript engine. Why? Because this way, if there are any asynchronous actions, we could always have the event loop keep working and working and working. We don't want to pause and block the event loop because it is the core. It's like the maestro. It's like the maestro of the orchestra. It is the one that, hey, go from here to go there. There is another function. Oh, I cannot trigger it now. Only when this one is empty, I'm going to trigger that. So that's basically how synchronous and asynchronous code works. Any questions?
No questions, Professor.
Let's take a small example before we continue. So if I would write in code here, so console.log, hello, 1, 2, and 3. This code is completely synchronous. It will run in sequence, node test.js. Probably I'm not in the right place. Yes. So node test.js, 1, 2, 3 in sequence. What happens when I add any asynchronous operation? So let's say my operation is a set timeout. Set timeout, it only means push this function at this time to the macro task queue. It doesn't mean execute this function after 0 seconds, milliseconds. So if I have here a function that's going to console log async, we will only see async after line number 3 finishes, completely finishes. If I run this code now, you will see I still have 1, 2, 3, and the last line is printing async. So that really tells me that this asynchronous operation was not processed until all my synchronous code was processed. It also tells me that this function was pushed to really run last. How? after 0 milliseconds, the function is scheduled in the microtask queue, but it was never able to be pushed into the execution stack until the stack is completely finished. That's why we see it last. Any questions about how this asynchronous code executed?
Excuse me, Professor.
Mm-hmm.
So here for the GS engine will execute on the synchronized code first in the stack, and then after all the stack in finish, this will execute the asynchronous in the queue macro, and it will push back to the stack, and it will continue to execute. Is it?
Yes. So if I would like to draw this, how it executes, you will see something like that. We have the 8 that's running in the stack 1, 2, 3, 4. This exact 1, 2, 3, 4 here. And now when we execute line number 1, we print hello 1. When we look at the code at line number 2 is something that V8 cannot process. So it delegates line number 2 to, in Node also we have some asynchronous environment. We're gonna talk about it tomorrow, to run this function after 0 milliseconds. And we understand now that the supporting asynchronous environment, this one is synchronous, is going to push this function into a queue. Now, after I delegate line number 2, I immediately jump to line number 3 and I print hello 2. Even the function is pushed already here, I can never deal with it until I finish all the synchronous code that I started to process. After line number 3 is finished, we process line number 4, we print hello 3. Now that my V8 is empty, we push this function into V8 to run. When this function is pushed later, it's going to print out lastly async. Does that answer your question?
Yes. So what happen if the line number 3 also the asynchronous, and the line number 1 will take the results from the asynchronous result from line number 2.
Mm-hmm.
So what's happened if I push it?
In this case, let's say we have 2 asynchronous lines.
Yeah.
Something like that, async 1 and async 2. Now, this asynchronous function doesn't rely on the first one to start with. Now, in case there are multiple asynchronous functions, they're all delegated to the asynchronous environment, and they will be executed by first come, first served. So that's why if I run now this code again, you'll see that asynchronous 1 is printed first, and then asynchronous 2. Okay? Now, what happens if the execution of this function depends on this result? This way, you need to nest callback functions. So the way we will do it is to have a set timeout inside the set timeout. So here is the first set timeout. Let's say here I have a value. I'm going to depend on, and then the next set timeout depend on this value plus value. The code is still going to run as 1, 2, 3 hellos, then async 1, and then the last async 2 with the value. Here it is, 1, 2, 3, still the synchronous code finished. Next, the asynchronous, first asynchronous function is pushed. And then after I receive the result, I'm gonna schedule the last one that's going to read the result. But now what we did is we nested callback functions. And it doesn't take a genius to say that this code is pretty unreadable. So after the break, we're going to learn a syntax with async await that is going to improve the readability of asynchronous code. But that's basically what happens when we have multiple asynchronous actions. Basically, they are executed in first come, first served by order whenever they are pushed into the macro task queue. Okay?
Yeah, thank you. Yeah, thank
Sure.
you.
Any questions?
Hi, Professor.
Yes.
Yes, what happened if we increase the timeout for the first set timeout function to 1000? Example?
So you want to increase this one to 1000?
Yes.
Yeah, so in this case, 1, 2, 3 immediately are printed. After 1 second, you will print this. And after that, you will schedule this function to print async 2.5 after we print async 1. So if I execute the code, 1, 2, 3, after 1 second, we see the results.
Okay,
Because this function is never pushed until this function is executed. It's never pushed right away. Okay.
So next, we move the set timeout inner set timeout into out of this function.
Okay. So I see that you want to move this out of this function, right?
Yes.
Okay. Now the value, I don't have value in this scope.
Oh, we remove it.
Yeah. So I'm gonna remove the value just not to see undefined and have these issues. So in the case where we have two asynchronous jobs, it's always first come, first served. And in this scenario, what happens is we're still going to execute all the synchronous code right away. Now for the asynchronous work, we are going to tell the asynchronous environment. Let's call this one function 1. Let's call this one function 2. We're saying to the asynchronous operation, I need function 1 to be scheduled to run after 1000 milliseconds. And I want F2 to be scheduled for running immediately. So regardless if the stack is empty or still processing, the asynchronous environment job is just to push F1 and 2 to the stack by this time. So you will see F2 is pushed by this time, which is 0. And after 1 millisecond, after 1 second, the F1 is pushed here. So regardless if this is busy or not busy, the execution will be always F2 and then F1. And now if I run the code, we see that 1, 2, 3, then 2, and the last is 1. Why? Because 1 is pushed later to this queue. So it will be pulled from the queue later. Did that answer your question?
Yes, yeah, what I got. Yeah, thank you so much.
You're welcome. Any other questions? Right, we are going to take a break for 10 minutes. And after 10 minutes, we will resume the lecture.
Okay, Professor.
Yeah, thank you, Professor.
You're welcome. welcome back everyone. So before the break, we looked at asynchronous processing and how JavaScript event loop works. We looked at something like this that exists in the browser. And that's basically, we're seeing here Chrome environment that has V8. Inside V8, we see the execution stack and the heap. And we have single-threaded event loop. This is where all the synchronous code processes, and this is where all the asynchronous work processes. Web API. The Web API job is just to push functions to the macro task queue. These functions are pushed in order, picked up in order through the event loop, one by one, to be executed synchronously inside V8. Now we also looked at a problem that we saw, which is like nesting multiple callback functions, especially when we had this one in here. That was an unreadable code. It's totally fine, but many times you read something from the parameter and then you need to send another request and then you're gonna send another request. Nesting all these asynchronous actions inside of each other make your code unreadable. And luckily we have a solution to this, which are promises objects. So what is basically the promise object? The promise object is an object that has asynchronous value. This is very common misunderstanding when people think about promises. Promises are not asynchronous. Promises, they have asynchronous value. So if you have a promise, the promise is synchronous, but the value of the promise is asynchronous. What is a promise? Before I show you any code, the promise is basically a value that's asynchronous. So a value that arrives later. That was the first thing I mentioned in this lecture. Asynchronous means later. So let's have some asynchronous work in here. So I'm gonna write down new promise. Const p equal new promise. Now this promise is synchronous. Everything creating the promise, executing this promise is gonna happen before we see hello 2. So the promise is literally synchronous objects. So if inside this promise I have, let's say, a callback function, and then I say console log promise, now I'm going to see 1 promise 2 3. So nothing asynchronous so far. We're seeing 1 promise 2 and 3. So it's literally the promise is synchronous. However, the promise has asynchronous value. So let's say I accept here a function that's called resolve, and I call this resolve to generate a value. This is promise value. And let's say I have here promise 1 and promise 2 as well. Now, with this piece of code, as I mentioned, everything is synchronous except for this line. Why? Promises have async value or async reject, as you might guess, but everything else is synchronous. So we're expecting to see now, hello promise 1, promise 2, hello 2, hello 3. And this is promise value last. However, we didn't see this printed at any time. The reason is there is no one to read this value. So how do we read the promise value? To read a promise value, you need to add a function that we're going to read the value to be pushed later into the stack and read this value. And we do that when we say p.then. So here is when we read the promise value. This is also asynchronous. So this is asynchronous. Why it's asynchronous? Because the value of the promise is asynchronous. So this function, basically that I pass to then, is pushed into queue to execute later after all sync is finished. And as you can see, we have 10 lines of code in this example, 10 lines of code. After the line number 10 is finished, now I'm going to execute this. So let's say I'm going to accept a value, and then I'm going to console log the value. Now I see that the last line printed was the asynchronous value of the promise. So the promise is synchronous. The value of the promise is asynchronous. So when this code executes, we print hello 1. Then we immediately create the promise object. Print promise 1. This is the value, it's asynchronous. Later. We immediately print promise 2. Any other code in here will be executed. This is now reading the value of the promise. It's also asynchronous. We continue with hello 2 and hello 3. Now this function is pushed later from the queue to read the promise value that we sent out in resolve. Now there is a shortcut. Since I need a function here that accepts the value and print the value, I can just pass a reference to the console log function like this, which is going to accept the value and print it out for me. Any questions? Anyone who did not, who doesn't understand promises, how they work previously, and they want me to elaborate a little bit about the promises?
Can you please elaborate the resolve method, what it does?
Yes. So the resolve function is basically to deliver the promise value. So to make this example a little bit more friendly, let's say here, this is pizza order. You want to order a pizza. And when you order a pizza, when the pizza arrives, what you want to do is you want to eat it, right? You want to consume it. So before you order the pizza, you were studying. And then you place an order for the pizza. The pizza order is an asynchronous action. Why? Because you order the pizza and you never pause. When you order the pizza, you receive a promise that we will deliver the pizza. So you hang up and you can continue studying. And then you can clean your room. And then you can take a shower. Okay? Let's say that as you are ordering the pizza, the pizza needs some specifications. So let's say ordering pizza. And then you specify something and you say, I need pepperoni pizza. So all of these actions, you have to do them before you continue studying. You start studying, you call for a pizza. You immediately specify, I need the pizza to be pepperoni. Doesn't matter this order. And then you receive a promise. So this is the real pizza value. This is where the pizza arrives. So resolve is basically delivering the asynchronous value later, which is going to happen when? After you finish your shower. Even if the pizza is ready and someone was at the door inside the queue telling you, yes, your pizza is ready, you can't now eat the pizza. Why? You are inside the shower or you're still cleaning somewhere you have to finish cleaning the room. You have to finish your shower before you can really eat the pizza. Now, what is line number 8 is, it's just your plan. That, hey, when I order a pizza, when the pizza arrives, I'm gonna eat it. I'm gonna print it. So this is just a plan. What do you wanna do when the pizza arrives? So the sequence of this code will be, I'm gonna study, order a pizza of my kind, and the pizza arrive later. Resolve is the pizza delivery, the asynchronous value that arrive later in the future. And this is your plan, that when the pizza arrive, I'm going to console log it. When the pizza arrive, I'm gonna eat it. However, since this line is asynchronous and this line is asynchronous, you can just know that this will be processed really later. So you will see studying, ordering pizza, studying room, shower, and after that, you will see the real pizza printed last. Let me print out this, execute the code. Studying. After studying, you order the pizza and you said that I need it as pepperoni. Then you immediately continue your study. Even this, the pizza is ready probably, or still being prepared. You don't care. You have to finish all 11 lines. So you clean your room, you take your shower. When you completely finished, now the pizza is resolved, and then you consume it and you print it out as a value into the console. Does that make resolve function more relatable?
Yes, that makes sense now. Thank you.
Welcome. Any other questions?
Professor,
I have a question.
Okay.
is it? Yeah. Sorry.
It's okay, Fong. You can ask your question first.
Yes. Is it correct that whenever we would like to read the date, the value of the promise, we only use .then?
Yes. In order, so see here, if the pizza is being prepared and you don't have a plan what to do with the pizza, which is like, for example, open the door and take it, then the pizza is a waste. Someone is going to throw it out and no one can eat it. So yes, a resolve without then, it doesn't make any sense. And then without resolve, it means the pizza is not delivered, so you will never eat it. So both these two lines need to exist in order for the whole process to finish. If they didn't deliver the pizza, you cannot eat it, even if you have a plan that when it arrives, I'm going to eat it, but it never arrived. So that doesn't work. And if the pizza people, they really work on the pizza and they came, they didn't find a house. No one is receiving the pizza. Then basically this value will never be printed, which is like what I did at some point here. Yes, this store is going to create the pizza and order and resolve, but there's no one eating pizza. So you need someone to accept the value and eat the pizza in order for the value to be consumed.
Is it the only way that we can get the value?
Yes, the only way that you can read a promise value is by adding .then. There is a shortcut later we will see with async to avoid these nested callback functions. But the standard way is to use .then. Any other questions?
Yeah, I have a question.
Yes.
Oh, I see the promise and the timer, the on the because I check that the timer will execute after the promise. That's why. Are there any priority between the promise and the timer?
Excellent question. Yes, I'm going to show you where the promises are in the event loop next, and explain to you why that is the case. But yes, there is a priority. I will explain it next. Any other questions?
Professor.
Yes.
Yes, please.
Yes.
Professor.
Yes, Rahel.
Yeah, my question is, so when we say promise, so from its meaning, promise is like it can be resolved or rejected.
Yes.
But from this example, that means we know the answer ahead, like it's going to be resolved.
Yes. Yeah. So it's a common practice that you accept here two functions. The first one is supposed to give you the value. Second one is supposed to give you an error. And here, based on the logic, so you can say if cheese is available, I'm going to resolve. Else, then there is no cheese, so you reject no cheese. So that would be, for example, when you use like resolve and reject. And you always need to set plans. So if the pizza is resolved, then you're gonna print it out. And otherwise, you should always have a plan to what if I didn't receive the pizza? So you should also set a plan what to do when the pizza doesn't. Sorry, this is not reject, this is catch. So that would be the syntax for when there's no cheese. This pizza order, later in the future, still in the same order, after you finish your shower, you receive a news that there is no cheese. So you just do whatever logic you need in this place.
Okay.
Does that answer your questions?
Yeah. So when there are both resolve and reject methods, so what is going to be the output now? Is it going to be resolved or rejected?
You should either resolve or you reject. So the promise object always comes in this shape, either value or error and end. You can never send a value and, or you cannot send multiple values. So you cannot multi-resolve. You cannot multi-reject. You either resolve with one value or you resolve with one value, and that's it. That's the nature of the promise. And basically, you either give this message or this message to be handled with .then or with .catch when the function is resolved or rejected asynchronously. So both of these are asynchronous, and both of these are asynchronous. Clear?
Thank you. Yes, thank you.
You're welcome. Any other questions? So if I said here the cheese is false, you will see all the synchronous parts still executed, and the last thing we see no cheese. So also reject is asynchronous, similar to resolve. And remember, you cannot have multiple resolve or multiple reject. You reject once, you resolve once. And that's not the case later in the third week when we learn about streams or observables, where you can resolve multiple values. But with the promise, one value only.
Hi, Professor.
Hi.
The promise, we only have two input is resolve or reject. I mean that can we have more than two inputs?
Yeah, you can have multiple inputs. So you can surround this function with another function that require multiple inputs. And based on the logic, you resolve or you reject. But you cannot call resolve multiple times. That's what I'm saying. Because if you do, only the first one is going to terminate this promise, send the value, and you finished. So you cannot multi-resolve. You have to place your logic in a way that you resolve once or reject once based on your business logic.
Yes. And another question that I see we have pizza order dot then and we just pass the console dot log, but we didn't have any input, but when it runs it still print the result. So why we just have console dot log?
This is a shortcut. So what is console log? Console log is a reference to the console log function. So let's say I have here a function that's going to say log that will accept a string and then console.log the string. So what do I do with this guy? I just pass it as reference, right? So I created a function called log that will accept something and print it out. So I just pass a reference to it instead of taking this function and put it here. Usually then and catch, they accept a function that will receive a value and you do something with it. So as a trick, I just pass a reference to the log function. Why? Because console log is basically a function similar to this one that's going to accept the value and print it out. So that's what I did when I just passed the reference here, because all I needed is to print the value out. But yeah, I see why you probably felt confused. But we usually pass a function that is going to do something. For example, this. And you get the value here, and you print the value there. Now, both of these lines are similar. This one will accept the value and you print it out. You do nothing else. In the line 14, I passed a reference to this guy immediately. So I'm passing a reference to a function, which is the log function on the console object. That is going to, whenever it receives a value, print it out. So basically, both are kind of like a shortcut to each other. Here you just have an extra wrapper, which is this function, this one. You don't need it. Does that answer your question?
Yeah. Thank you.
Good. You're welcome. Any other questions?
Professor, I'm sorry, I got confused a little bit.
Yes.
So promise is it's synchronized, right? But it has
Yes.
a synchronized value.
Good. Yes.
Okay, so what if we wanted to do? So it's since it's synchronized value, but we have to. What if that value? I just don't understand. Okay, so for example, we can see that not value to console log that ordering pizza is synchronized. But what if we have the value there? So it has to be all the synchronized executed, then we have the value, right? Like
I didn't quite understand the question. Can you elaborate?
yeah, so promise has a sync value, right? So that means the sync has sync value executed all after all the synchronized execution.
Yes,
Because
so the value, yeah, so the value would be consumed after all the synchronous code is finished. Yes.
Right. So, but in all this middle of all the synchronized execution, we have promise in the middle, right? At the sync value, we wanted to execute in the middle, but it has to be executed all after synchronized execution. Does it make sense?
Yes. So that's why I don't like to say promise are synchronous. We like to say promise is eager. So immediately is created and executed, and it has an asynchronous value. But to tell you from the beginning that the promise is eager, you wouldn't understand what it means. So all it means promise is eager is it's executed right away and synchronously until you resolve. So that's why the value of the promise is asynchronous.
Right, value of the object is synchronous. But what if we wanted, I mean, it's...
what if you want to send a value during the synchronous?
Right.
You can do that with the promise.
Okay,
the promise
so I can
will
do
never,
that.
yeah, this function here inside then can never be executed before taking a shower. Never. So the promise cannot deliver synchronous value. The promise can only deliver asynchronous value. The other stuff are just eager because the nature of the promise is eager, are processed before we receive the asynchronous value. That's it. But you cannot deliver a synchronous value inside the promise.
Thank you.
You're welcome. Any other questions?
Hi, Professor.
Yes.
I have a question not related to promise, but I would like to understand why not the engine should design the only one envelope instead of multiple envelope. When we have currently we have multiple core, multiple processors, something like that.
We will discuss all of these details tomorrow and after tomorrow when we talk about Node.
Okay.
Yeah. Today, we want to focus on the browser, how the browser event loop works. Now, you might ask me why the browser has a single event loop. Because web applications did not need more when they started. And you will see later that how a single event loop is more efficient than multi-threaded system. We will talk about this again in more details tomorrow. I will explain why it's more efficient. Excellent questions, but just ahead of the time. Any other questions? Okay, now let's just understand a little bit more about the nature of this asynchronous code. So when this code is going to execute, we still have here even V8, and we have 1, 2, 3, 4 to execute. When the promise arrives, it's delegated to the web API. Actually, the promise is not delegated to the web API, to be very honest with you. And the reason is promises now are part of the language. Promise is part of the language, JavaScript language. So we see it implemented as part of V8. That's why next to V8, we will see a different queue, which is the promise queue. And this promise queue has a name. It's called microtask queue, which is different than the one that we see with timers and other like asynchronous actions that we perform with the web API. When these APIs finish callback functions and they need them to execute, they push them in a queue called macro task queue. And this macro task queue can only work with the event loop. This queue has nothing to do with the event loop. So the event loop only picks up functions that are scheduled in the macro task queue, like timers and intervals and others. Now, whenever you have an asynchronous value that resolves in a promise and you have then, the function inside then is scheduled inside the micro task queue. And now when your synchronous code finishes here, V8 is going to pick up functions from the promise queue before it allows the event loop to push any more functions. So all the work in the left side need to be completely finished before the event loop allows any work from the macro task queue to be picked up. And that's why we say the promise queue has more priority than the macro task queue. However, the mechanism is completely different. So whenever I have functions in the promise queue, when the V8 is finished here, V8 is going to pick up functions from the promise queue and process them one by one until the promise queue completely drained, empty. Only we allow the event loop to pick up functions from the macro task queue. That's why this queue has more priority. So if you have any kind of code that has nested promises and timers and stuff, you will always see the promise callback functions are triggered before any work picked up from the macro task queue. So that's basically how or where the promise asynchronous values are scheduled and how it executes. It executes as part of the work from V8. The event loop is not involved in the work from the picked up from the promise queue. Any questions? Let's see code examples and elaborate more on this. Are my code examples? Oh, yeah, I cannot show you code examples. I can only show you code examples after we learn async await because it's just syntactic sugar. So what do I mean by syntactic sugar? We learned the syntax for promises, and the promise is nice. However, what about this .then? Let's say inside .then, I have some work that requires some extra work. So let's say after I catch, I need to print it out, And then maybe do another asynchronous work, which is log in DB. Another async work. And that will require at some point another then and another callback. So easily we can nest now multiple callback functions that will make our code, again, very nested and unreadable, but totally fine. So to improve readability, they created a shortcut called async await, which just makes the code more readable. And simply to convert this code to use async await, you can say const pizza equal, you call the pizza order here. Let's say it's a function. And then you wait for this function. So this line is shortcut for .then. Everything that you will have inside .then, you can just place it after await. Let me show you a better example for all of that. Let's say I have const order pizza, which is a function. Resolve. I'm just gonna resolve for now. Oh, this is just a function, sorry. I don't need this. Now this function, whenever you order a pizza, you usually have .then, right? And then the pizza would arrive. And then you do something with it. When you order a pizza, immediately the pizza store is going to return a new promise object. Okay? And then they will prepare the pizza, do some stuff. So they are all synchronous. So here we can say console.log pizza is being prepared. And after it is prepared, you deliver the pizza. So you say resolve pizza. So the way this code executes is you start by ordering the pizza. The pizza is immediately being prepared. This line is async. Next, everything inside then is async. So before ordering the pizza, we could do some synchronous work. So let's say log studying. And only after you finish, and then you can resume studying. So the way this code now is executed is, you start studying, the pizza is start preparing because you ordered the pizza, and then you resume studying. And only when you finish studying here, now you can deal with the asynchronous work, which is you receive this pizza, so you wait 5 minutes, you slice it, and you eat it. Let's execute this code, confirm this. Yes, I study, the pizza start preparing, and I continue my studying. When I finish studying, now I can wait, slice, and eat the pizza. So far, nothing new. So how can I make this code readable, more readable than this? So,
Professor,
yes?
why did line number 8 printed before line number 3?
Oh, because this is just a function definition. This is just a function definition. It doesn't execute before you call it. Here I just declared a function, and then the second thing is like I could print studying, and now I call the function. That's why we see studying before anything inside the function, because the function is called after. This is just function declaration. Okay. Any other questions? So how can I improve the readability of this code? You see everything inside then. I can take it all out and place it in the next line. Just like this. How do I receive the pizza? I can simply say const pizza is wait pizza. Now all of these lines become inside .then. So every single time you see wait keyword, it means the function next to it is returning promise. And it also means that all the lines after this is inside some sort of a then that will be at some point in this scope. Since we don't want to add .then, we want to make the code more readable. Now this code will give you the reasoning that this code is synchronous, but actually all of these lines after await are asynchronous. So let's see what happened when I run this code. It didn't work. And the reason is, in order to use await, you need to wrap it inside a function marked with async. Okay, let's do that. Since I don't want to resume studying after eating the pizza, I'm going to execute this last line. And now what I can do is take this code, wrap it inside different function. Yeah. Here's a function. And I need to mark this function with async. Why? Because inside this function, I'm going to use await. But now this function will never execute. So let's call it together as an immediately invoke function. So what I created here is a function that calls itself, but marked with async. This way I can use await. Now again, all await is doing is just a shortcut for taking all of these lines after await. Instead of adding .then, I don't want to do that. I place them after await. But now that all of these are asynchronous. So now again, this is function declaration. Does nothing when you execute. You study. You call this, so you start ordering the pizza. So the pizza should start preparing. Then you resume studying. When you finish your studying here at line 15, that's when you receive the pizza, you wait, you slice, and you eat. Let's confirm that. Yes. We study, We order the pizza, so the pizza start preparing. Then we resume studying immediately. When we finish the studying, that's when we process the asynchronous actions that will process after line 15 is finished. So we wait, slice, and eat the pizza. So the await syntax is literally just, we call it syntactic sugar for the .then syntax to be processed after this promise resolve. Any questions about await syntax?
Professor, so
Yes.
we basically just putting the resolve into the wait, and then it's calling the function order pizza, and then pizza variable comes
Yeah,
waiting
so
the process and then coming out.
correct. So after studying, I have a function that's immediately invoked. So we process all these lines. And this line is going to call order pizza. But since it has await, this await is just simply shortcut to .then. Here, instead of .then, I put the value inside this variable, and then I continue asynchronously with the next lines. So the next lines are processed after 15, even though the promise is really going to deliver immediately. Yeah.
So, Professor, I have a question.
Yes.
So that async function will push the to the macro or micro queue.
Yes. So basically, all these lines are pushed inside, are wrapped in a function and pushed inside the micro task queue to be picked up after we finish studying. So this one is just a shortcut to .then function. We receive the value and process the next lines. It's the syntactic sugar. But we still have a function that is going to receive the pizza and then do the stuff instead of this wait pizza, blah, blah, blah. This is the result of the code, but we're not seeing that. What we're seeing is this syntax. But this syntax doesn't mean that I don't have now a callback function pushed onto the macro task. There's still a function. We'll accept the pizza and schedule this code to run in the micro task queue. This is just syntactic sugar. It's like fake. It's like when you put the glasses and you see the real thing. Similar, yeah. So it's just a shortcut, not shortcut, literally syntactic sugar.
Okay, thank you, sir.
And you're welcome. And wait, since it requires like a function to be set in a function that's marked with async, that was a requirement that started when they first introduced the wait syntax. But these days, there is something called global async. So async exists on a global scope. So you don't really need it. So I assume browsers, they already have a global async. So you don't need this wrapper. You literally don't need it. And I think the next release of Node also has global async, so you don't need to wrap with this function. But to make your code runs in all environments for now until everybody upgrades, then you still need to wrap your await with a function that's marked with async. So that's still, I would say, write it up, even if you're trying to run the code in an environment that has global async, just to be safer that this code will run in other environments that don't have global async. Leave the async function out there, safer for now. Maybe in a year, I would change that and remove this async thing.
Professor, I have a question.
Yes?
How does await deal with a rejected promise?
Very good question. What if the pizza is going to reject? It's common that you always surround your code with a try catch. And then put your code inside try. Now here is where you deal with the reject. So in case the ordering pizza rejected, we never process these 3 lines. Instead, we process these 3 lines. Cry more, and then you could sleep in tears. So these 3 lines are wrapped in a function and inside the reject, and they will be executed in case the order pizza rejected. So that's how we deal with rejection. Surround your code with try catch. If the pizza all good, we process this. If the pizza rejected, we process this. Any other questions?
Yeah, and when we're using a global async, how do we tell which lines are linked with the await, like which lines of code are async and which lines are sync?
All of the lines after await are going to be async.
Oh, okay.
All of them in the current scope. So here inside await, these are all the lines, all of them. That doesn't mean this line. This line is out of this scope, right? So that's why it's rarely that you use the or the global async is useful too much, because sometimes you just want to do something asynchronously and continue synchronously. So it's a rare case. A good question.
Yeah, thank you.
Any other questions?
Yes, Professor.
Yeah.
The keyword async before function is just let the GS engine know that this is the asynchronous function and it will push into macro task queue, right?
Doesn't do anything. This async inside the function does nothing to the function. All it does is it's a requirement to use await. Using this async keyword, it's just a requirement for await to be used. It doesn't do anything to how the function executes. The function is still executing synchronously.
So when we use the await, we will declare the async functions.
Yes, only when you use await, you declare it inside a function that has async.
Oh, okay. Yeah. So what's happened if we don't declare? It will still execute immediately, or it will still understand?
You see this? When I try to use it without this function, I received an error saying await is only valid inside async functions and the top level bodies of modules.
I got it. Yeah.
That's not my case.
Yeah. Thank you.
Any other questions?
Yeah, the professor. So for the await default, how long we can wait? Do we have any way to set the timer for the await?
Say it again. Do we have any way to set timer?
So in the line 11, we are using await. So do we have default timing for await? Can we change the timer?
Oh, await is not timer. Await, it's at syntactic sugar.then. So the question I'm gonna ask you back is, can you delay .then to be triggered at some certain time? Wasn't that the question? Can I run this after certain time? Was that your question?
Yeah. So I see
So, okay, the dot await is simply .then. So this is so simply .then. You get the pizza, and then you process these lines. So the answer is no, you can't, like, because once the pizza resolve, these are pushed to execute later. So if you wanna execute this later at a time, you have to surround them with a timer yourself. Okay?
Understood. 10
Yeah. So this await syntax is just simply shortcut for .then. That's it. Any other questions? I would like to spend the last few minutes left in this lecture working with some examples to evaluate code and show our understanding to promises and the event loop, basically. So here I have some code. Let's evaluate the code together and figure out how this code is executed. 1, 2, 3, 4, 5. We have 5 things in this code. Calling console log, function declaration, calling a function, console log, and function declaration. When we execute the code line by line. And let's see what happened inside the microtask queue, and event loop, and macrotask queue. Right? First, start need to be printed. 1, 2, 3, 4, 5. Only after 5, note here that only after line number 5, we start running asynchronous work. Starting with the micro. When the micro is done, the event loop pushes anything inside the macro. Okay, so the first line is going to print start. Next, I have function declaration, fine. 3, call a function called my function. I'm gonna call it, execute this one. Let's call it print A. Right? Immediately. Now I have called my promise task. I'm calling my promise task. And the value needs to sit inside inside the result. But I surrounded this with await, which means this line is inside .then. So this line is async. This line is not async. The line after await is async. Only the lines after await are inside .then. Now let's execute my promise task. My promise task is hoisted, so I can execute it before it is declared. Let's run my promise task. When we execute this code, now we return a new promise. The promise is eager. Everything inside this promise is considered kind of synchronous, or we will execute right away, except for this line, right? So when the promise is being created, we're going to print C and D. Only this line is asynchronous. Now we finished my promise task. This line will never execute. Why? Because it's asynchronous. It happens after await. So it's quite similar to having this line inside .n. After I finish my function, now I'm going to execute line number 4, which is end. Now we finished all the synchronous. Line 5 is function declaration. We finished. Now we reach to this line, which is finishing all the asynchronous processing. What's left for me? Then this line. Now we take this function, consider it trapped inside a function here. That's going to receive the value that we sent inside resolve. So this string is passed, assigned to the results. This line is pushed this function. The function is pushed to V8. The last thing we see the string task results. So that's the execution order. All the synchronous parts and then the asynchronous parts. This is simple because it has only one promise call. Any questions?
Yes, Professor. So the console.login, shouldn't it come after the start? Because that is synchronous.
Okay, let's see. Let's see. So first we start with number 1. Number 4 will execute after 2 and 3. If we didn't finish 2 and 3, we cannot process 4, right? Okay, so we start with 1, execute. Now 2 is just a function declaration. We never call it. Now we need to finish 3. You cannot print 4 before you finish 3. 3 is calling this function, so we are executing this function. When you execute this function, now you need to process all the lines inside this function, the synchronous line in this function, before you move to 4. When you call this function, you print A. Now you finish number 2. To process number 2, you are calling another function. So when you call another function, you have to process this, which requires printing C and D as synchronous. Only when you finish all of these and you finish this line, now 3 is asynchronous. We don't process it now. Now we finish line number 3, we move to line number 4, and we print end. Make sense? Any other questions? Let's have one more question example. Oh, there's no more example. There's no more one example. That's good. The last few slides, the last 3 slides, you can just they just tell you that the fetch API that you probably know already that sends HTTP request usually returns promise. That's why you see always .10. And when you parse the response, also this call returns another promise. That's why you can follow that up with another .10. And you can always improve the syntax of fetch request by using await. Imagine all of these surrounded with global async. That will literally make the code more readable while it's still asynchronous. Hey, fetch, await. When the results arrive and finish and I can deal with it, I'm gonna parse the body. If the body is huge, when I finish parsing the body, I can continue with the code. So literally wait, make the code more readable. We will not use fetch in the client side because Angular has its own fetch. We will explain it in more details in the last week. So that's it for today. Hopefully that brought better understanding to the event loop in general, the queues, how asynchronous work in JavaScript. And finally, I would love to have all of you guys comfortable reading code with async await, like this one. So try to really focus on this in today's studying. For the homework, so the first step is to go to Sakai and then click on a link from Sakai. So on Sakai, you will find a link, resources, you find homework, and then you click on the homework, and that would open up a window that tells you accept this assignment. So once you accept the assignment, you will see repository created for you that looks like this. So after you accept the assignment, you are welcomed with a repository similar to this one. So what do we do with this repository? You just clone it and then push your answer back to it. That's basically how you submit the homework. If you need help with this process, contact me, I can help you with it. So this homework for today is simply about understanding the event loop. So we see 2 questions. Explain the JavaScript event loop in your own words, based on everything that we explained today, clarifying the synchronous parts, the asynchronous parts, the both queues that we learned, which one has more priority than the other and why, and give some example. So answer this question as if it was a real interview question. And second question is basically, how can we convert a synchronous operation or a synchronous function to become asynchronous? So I have a function that's basically synchronous. How can I convert that to become asynchronous? You need to use an asynchronous operation, like timer, like promise, surround it with a promise. These are all ways to process this code asynchronously later. So also give some example on how you converted function or operation to run asynchronously. The afternoon session starts at 2 p.m. That will give all of you time to go and be still social distanced, have your food, come back to your dorms, and then we will start another stream online. We join, and the first few days, probably we won't have too much work to do in the afternoon session, but in the upcoming days, we're certainly going to code more together and go over the previous homework together, so they will be more interactive. For today, we're just gonna join the stream, and if you have any questions, send it in the chat, send it in the channel, and I can assist you either one, or we can have a group discussion. For now, we will meditate and then go to lunch.